Hello, in this video I am going to talk about the way that I mounted the battery. So let me start with first talking about the way that I put a platform in. So I bought 8 by 10, I believe, 8 by 10 inches of flat plastic panels. So this just barely didn't fit in between these two beams, so I had to cut along the edge of it, cut off about 2 millimeters to get it to fit in between the beams. But then I also had to drill the holes in the panels themselves. But the thing is, I used the holes. I took this top frame off, and the holes did not exactly match up with the bottom, or maybe the way I drilled the holes, they did not exactly match up. So I had to keep, when I pushed it in, I did not want to force it, so I would try to drill and try to weigh down the hole or widen the hole by rotating the drill around the hole to try to widen it up. And I think that caused too much stress, that and then I used a bigger drill bit, and it caught on the first attempt and it broke that panel. So you have to be careful when I realized that when I have to drill or cut, I have to be very gentle and mind the pressure when I press the drill. Be gentle with that and work slowly as you make the holes with these panels. Otherwise, you would end up with the panel cracking. But at least the panel is not that expensive. I have the receipt here, and I don't know if you can see, but it's only about $4. So to me, that's cheap. I bought about 4 more, I think. 4 more panels, I think I have. And I already had one wider panel that I'm going to use for the top of the robot platform for the robotic arm. So I finally had the panel placed as a shelf, as a platform. Then I installed an extra cross beam here that's just wide enough to place the battery inside. And I used, if you can notice, I used more nuts and bolts to secure the battery into place, so they would, so when the robot moves, it would not, the battery will not move too much. And the padding is also around the battery. If you notice, there's padding around the battery, so it doesn't get damaged by the hard screws and the threads. So then I used some Velcro to hold the battery in place so it would not lift off, or if there's an accident and someone crashes into the robot, the battery should remain in place. So, oh, by the way, I drew a template of the bottom. If you notice the holes, I placed this, I took this whole bottom frame off and I placed it on this paper, and I drew the holes, so if I needed to make templates for below this top platform, it should all, the holes should all line up. So that's the process I used for mounting the battery on here. But now let's talk about what I'm going to do in the future progress of this build. So I found, just by looking around, I found a 12 volt voltage, what do they call this? A dual USB power outlet. I found this, it's 12 volts, and it has a overload protection, that automatic overload protection. And each one of these USBs provides, I believe, 2.1 amp max. And if you use the two USBs, well, at 5 volts each, if you use the two USBs, then you get 1.5 amp each max. Here's Rory, my cat. I had to close the doors, the garage doors, and he wants to get outside. So I'm trying to rush this video, and then I'll open up the garage doors again. There's just the neighbors are talking, and I didn't want the video to have too much noise. So he's jumping on the car right now. Okay, so then there's the this is the cigarette lighter. It provides 12 volts supply. And then I found next to the same location that I found this in the store, I found this accessory plug. It's also rated for 12 volts, but it has a max current as 5 amps. So the max current for the DC motors are 4 amps. So 5, if when it stalls out, each DC motor will drain about 3.65 amps, and told us more than 6 amps. So that to me is I need to have some type of protection, and there's a fuse inside of this one. So the fuse is rated for 5 amps. So once I connect this to the battery, I will then be able to send power to the motors, the DC motors, with this accessory plug. And I like that they both have LED indicators for their operation. But I also have a master switch. This is a master switch that I will be using. It's going to be connected to the positive supply, the shortest connection out of the positive to this, and then the positive to this goes to the I would call this a voltage regulator. It's a current regulator in a sense. You have voltage too, because you get 5 volts for the USBs. And so that's where I am in my current process of building the robot. I am also working on other parts in parallel, but this is the sequence that follows with the battery. So thank you for watching.